Welcome to This Explainer. Today, we're uncovering the secret history and, honestly, the pretty surprising family tree of the invisible software that runs our entire digital world. We stare at screens all day long, right? But we rarely stop to think about the digital engines humming just beneath the glass. Well, let's map out that hidden genealogy.
Think about it for a second. Every single tap, swipe, and click you make relies on a foundational program that boots up the second your device powers on. It's not an app, and it's definitely not a website. It's the silent infrastructure making the whole shebang possible. So, what actually is it?
Let's kick things off with Section 1, the Invisible Digital Manager.
Look, without an operating system, your device is basically just an incredibly expensive, glowing paperweight. This tireless, behind-the-scenes manager has a few absolutely essential jobs. First off, it manages the processor, deciding which program gets to run and switching between them so incredibly fast it literally feels like they're running at the same time. It also protects your memory, so one program doesn't accidentally overwrite another's data. It organizes all your storage through a file system, handles all those complicated hardware drivers, and, this is key, it actually gives us humans a way to interact with all this underlying chaos, whether that's typing in a command line or just clicking around a graphical interface.
Moving right along to Section 2, Unix, the Big Bang. To truly understand how we got to the incredibly powerful smartphones sitting in our pockets right now, we have to rewind a bit. Back in the 1940s and 50s, computer operators had to feed instructions into these massive machines directly, literally one punch card at a time. A single task could eat up your entire day. Through the 50s and 60s, scientists started building early operating systems just to automate that tedious work. But the real Big Bang of modern computing, that happened in 1969. A team at Bell Labs, including legends like Thompson and Dennis Ritchie, created Unix. They wanted something way simpler than the bloated systems of the time, and Unix was built on this beautifully elegant idea. Absolutely everything, a physical device, a program, a piece of data, was simply represented as a file. It relied on small, simple programs that just did one thing really well, and you could easily string them together.
And here is a totally vital piece of the puzzle. Unix was largely written in a brand new programming language called C. Since Dennis Ritchie actually created this language alongside the operating system, Unix became incredibly portable. It could be adapted to run on completely different types of hardware with very little tweaking. So during the 1970s, AT&T decided to license the Unix source code super cheaply to academic institutions. Because of that, it spread like wildfire through universities. Whole generations of students absorbed its incredibly effective philosophy. Which brings us to Section 3, Windows dominates the PC.
Okay, so while Unix was evolving inside the walls of university computer labs, a totally different story was unfolding out in the consumer market. And it was all driven by one pivotal decision in 1980. Bill Gates and Paul Allen had founded Microsoft in 1975, right? Well, when the giant IBM needed an operating system for their new personal computer, Microsoft adapted an existing system into what became MS-DOS. But here's the kicker. They didn't just sell it to IBM. Microsoft brilliantly negotiated the right to license MS-DOS to other manufacturers too. So as dozens of companies started building IBM-compatible PCs throughout the 1980s, nearly all of them licensed MS-DOS. That single, monumental move literally overnight turned Microsoft into the dominant force in PC software.
There was a catch, though. MS-DOS was entirely text-based. No mouse, no icons, none of that. So Microsoft layered a polished graphical interface over it, releasing the first Windows in 1985. But the real game-changer came with Windows 95, which combined a fantastic graphical interface with major under-the-hood improvements. From that exact moment on, Microsoft secured a global PC dominance that they've held ever since, right through to modern iterations like Windows XP, 7, 10, and 11.
All right, Section 4, Linux, the free revolution. Meanwhile, back in the 1980s, the Unix world had splintered into all these different corporate and academic versions, and much of the original code was locked down by AT&T, meaning it just wasn't freely available for people to study or modify. Well, this really rubbed a programmer named Richard Stallman the wrong way. So, in 1983, he launched a project to build a completely free alternative. His community built some amazing free tools, but by 1990 they were missing one absolute deal-breaker: the kernel. As you can see defined here, the kernel is the absolute core software that directly talks to and manages the processor, memory, and hardware. Without a kernel, you just don't have an operating system.
Well, that missing piece finally arrived in 1990-91. A Finnish computer science student named Linus Torvalds, working mostly by himself, wrote a brand new Unix-style kernel. He named it Linux and just released it publicly on the internet. Crucially, he released it under a free, open license for absolutely anyone to download, study, modify, and redistribute. Combined with Stallman's tools, the world finally had a completely free operating system.
And because it was free and open, it spread rapidly. Massive companies even started packaging it into distributions you might have heard of, like Ubuntu, Red Hat, and Debian. Now, Linux didn't exactly conquer the consumer desktop market the way Windows did, but it conquered something arguably much more important. Today, Linux completely dominates the background servers. Every single time you browse a website, stream a movie, or pull something from the cloud, you are relying on Linux.
Let's pivot to Section 5, iOS and Android emerge.
Now let's move into the mobile era and talk about those devices sitting right there in your pocket. Apple, founded back in 1976, popularized the graphical interface with the 1984 Macintosh, an idea they famously got inspired by from research at Xerox PARC. But by the late 90s, their original operating system was really showing its age. So in 2001, Apple made a pivotal, historic decision. They completely rebuilt Mac OS X on a Unix foundation. This gave them decades of rock-solid Unix stability underneath their beautiful, polished interface. And later, when they needed an incredibly efficient system for the brand new 2007 iPhone, they adapted that very same Unix-based core into what eventually became iOS.
Android's lineage, on the other hand, looks a bit different. It actually began as a small startup that Google acquired in 2005. When the iPhone dropped in 2007, it massively accelerated Google's plans, pushing them to rebuild Android entirely for touchscreens. But rather than building a new kernel from scratch, Google built Android directly on top of the open-source Linux kernel, adding their own mobile-specific software layer on top. This whole system debuted commercially in 2008.
And this brilliantly illustrates the divide that totally shaped the modern smartphone industry. Apple treats iOS as a tightly controlled exclusive package. They build the hardware and the software, and iOS only ever runs on Apple devices. Google, though, took a page right out of the old Microsoft playbook. They broadly license Android for free to worldwide manufacturers. That is exactly why companies like Samsung and Sony can build highly customized phones, which gives Android the massive global market share it enjoys today.
Yet even with those intensely competing business models, both iOS and Android actually work in incredibly similar ways under the hood. Both rely on a core kernel to manage the physical hardware. Both heavily isolate apps in secure sandboxes, so, one misbehaving app can't just crash your whole phone. Both are designed to aggressively optimize your battery life. And of course, both are entirely centered around touch interactions and notifications, completely leaving the traditional mouse and keyboard behind.
Which brings us to Section 6. The shared digital DNA.
All right, this is the grand reveal of our explainer, the incredible twist hiding right inside our digital family tree. When you look closely at the software lineage, almost everything we rely on today shares the exact same foundational DNA. And it was all born in that 1969 Bell Labs project. It is just an incredible thread connecting our modern digital lives back over half a century.
Seriously, trace the branches of this tree. Linus Torvalds Linux, which powers the world's web servers and serves as the kernel for literally every Android phone, alongside Apple's Mac OS X and iOS, they all trace their direct ancestry right back to Unix. These supposedly distinct, rival platforms are actually part of the exact same sprawling digital family.
When we step back and look at the whole picture, we see that Windows alone stands out. Born from that super-specific 1980 IBM business deal and propelled by the insanely broad licensing of MS-DOS, Windows followed a completely separate, independent path to its dominance on the personal computer.
It is just fascinating how these layers of history build the modern world. So the next time you tap your screen, save a file, or unlock your phone with a quick glance, ask yourself, what other invisible, intertwined histories are quietly shaping the world around you every single day?